Welcome to Teacher Gimble's channel. Today we're going to go over Illustrative Math, Algebra 1, Unit 1, Lesson 16, Practice. We made it to the end of the unit. Good work. If you like this video, make sure to press like and subscribe so you can see more like it. Let's get started. Problem 1. Here are the statistics for high temperatures in the city during October. We have a mean of 65.3 degrees Fahrenheit. We have a median of 65.3 degrees Fahrenheit. We have a mean of 65.3, a median of 63.5, a standard deviation of 9.3 degrees, and an IQR of 7.1 degrees Fahrenheit. Recall that temperature C is measured in degrees Celsius is related to temperature F measured in degrees Fahrenheit by C equals 5/9 times F minus 30. Describe how the value of each statistic change when 32 is subtracted from the temperature in degrees Fahrenheit. This is very similar to a question we saw in the last problem set. When we subtract a constant value, it's not going to affect the shape of our distribution. Our whole distribution is just going to get shifted to the left, or it's going to get shifted to the right. So the statistics, let's see how they would change. The mean of degrees Fahrenheit, it's going to get shifted 32 degrees to the left. So when we subtract 32, 65.3 minus 32 is going to give us our new mean, which is going to be 33.3 degrees. Well, it's going to give us our new mean when we subtract 32, not in degrees Celsius. Describe how the value, we have to do our other statistics. The median of the degrees Fahrenheit, again, the median is going to be the same number, but it's going to be shifted 32 degrees to the left. So our median is going to turn into 63.5 minus 32, which is going to give us 61.5 degrees Fahrenheit. Our standard deviation of 9.3 degrees Fahrenheit. All of our data has been taken and shifted to the left. The spaces between the data, or the variability, has not changed. So the standard deviation, when we shift 32 degrees to the left, is still going to remain the same. The IQR of 7.1 degrees Fahrenheit, again, our data, the distance between points has stayed the same. So although Q1 has changed and although Q3 has changed, the distance between them, or the difference between them, has not. It has stayed the same. So your IQR is also going to stay the same. Let's look at the next question. Describe how the value of each statistic further changes when the new values are multiplied by 5/9. So we know we've been shifted to the left 32 degrees. Now each value is multiplied by 5/9. However, even though we shifted to the left, if we're multiplying each value by 5/9, that's going to make 5/9 of a difference, and it's going to keep our median at 61.5 times 5/9. Our median, it's going to do the same thing. Our value of our median is going to be 61.5 times 5/9. Now our variability, in this case, when it got shifted to the left, it did not change. But now that we're multiplying it by 5/9, our standard deviation in this case, it's not going to be the same. It's going to be 5/9 times our original standard deviation, which in this case was 9.3 degrees Fahrenheit. The same is going to be true for our IQR. Our IQR does not stay the same in this case because everything is being changed by 5.5 over 9. But in this case, it's going to be 5/9 of our original IQR. Now it says, describe how to find the value of each statistics when the temperature is measured in degrees Celsius. Well, that's pretty straightforward. We have our formula, which is Celsius is going to equal 5/9 times F minus 32. So for the mean and the median, we're just going to plug it in. So let's do a little bit of mathematics here. So for the mean and the median, we're going to have 5/9 times 65.3 minus 32, and that's going to give you your answer. For the median, we're going to have 5/9 times 63.5 minus 32, and that's going to give you your answer. Plug it into a handy dandy calculator that I am sure you have access to and calculate that number yourself. Now, our standard deviation, he didn't have any effect with the 32 degrees, so all he's going to be is 5/9 times the original standard deviation. And the IQR, it's the same thing. He didn't get affected by the minus 32 degrees, so it's going to be 5/9 times 7.1. So our mean and our median get shifted to the left and multiplied by 5/9, whereas our standard deviation and IQR only get multiplied by 5/9. I'm going to move on to the next question, but if you have any questions or need to look this over again, pause the video here to go ahead and give it a second look through, or post questions in the comments. Problem 2. Here is a box plot. Give an example of a box plot that has a greater median and a greater measure of variability, but the same minimum and maximum values. I'm going to do a little bit of cheating here, and I'm going to draw my box plot on the same number line. So we have the same min and the same max. We want to have a greater median, so let's make this our median over here. And we want to have a greater variability, which means our variability is going to be, our IQR is going to be wider. So I'm just going to draw a box that's longer than my original box. So there's my new box plot. Our min and our max are the same. Our median is 75 rather than 50, and we know the variability is greater because the box is bigger. And that's it. That was pretty easy. Let's go on to the next question. Problem 3. The mean vitamin C levels for 20 dogs was 7.6 milligrams per liter, with a standard deviation of 2.1 milligrams per liter. One dog's vitamin C level was not in the normal range. It was 0.0 milligrams per liter, which is a very low vitamin C level. So we have, this is our mean value, this is our standard deviation, and we have this amount that happened to one of the dogs, which is not normal. If the value 0.90 is eliminated from the data set, does the mean increase or decrease? Well, the mean is 7.6, and 0.90 is a very low value, which means it's going to pull our mean to the left. So when we remove it, our mean actually gets higher. So in this case, it's going to increase. If the value 0.09 is eliminated from the data set, does the standard deviation increase or decrease? Well, when we have our standard deviation, which is 2.1, we know it's pretty standard to deviate about 2.1 below or 2.1 above. However, 0.09 is a deviation that's very, very low. So that's going to make our deviation seem higher than it actually is for the rest of the data. So if we're getting rid of the outlier, the standard deviation is actually going to decrease because the rest of our data are going to all lie closer to 7.6 milligrams. Let's go on to problem number 4. The data set represents the number of hours that 15 students walked during a 2-week period. So we had some students walking 6 hours, some students walking 30 hours. That's a lot of hours to walk. The median is 10 hours. Q1 is 8, Q3 is 14. The IQR is 6 hours. So I'm just going to circle all of my data. Are there any outliers in the data? Explain or show your reasoning. So we have 2 formulas to figure out IQ outliers. One is going to be to figure out if the outlier is greater than all of the rest of our values, and the other is to see if we have a lower IQR. These are the 2 formulas that we're going to use, and both of them are going to rely on this 1.5 times IQR. So we have our IQR is 6 hours. So to check out to see if we have a higher outlier, we're going to have our IQR, which is 6, times 1.5, plus Q3, which is 14. And I'm actually going to go above for this. We have 6 times 1.5, which is 9, plus 14, which gives me 23 as a final answer. 30 is greater than 23, so this right here we know is an outlier. So we have one outlier. Let's check to see if we have another one. Honestly, looking at the data, I see that we have these 6, 7, 8 all the way down here, 9, 10, and I do not think we have a lower outlier, but we can check it just in case. So we have 8 is our Q1. We already calculated our IQR times 1.5 here, which is 9, which gets us -1. We do not have any values that are negative numbers, so there are no lower outliers. So yes, there's an outlier, but it is only that 30. If you need a second to pause this video to go over the calculations, feel free to pause as I move on to question number 5. Here are some summary statistics about the number of accounts that follow some bands on social media. So we have a mean, a median, a standard deviation, a Q1, a Q3, and an IQR. Give an example of a number of followers that a very popular band might have that would be considered an outlier for this data. Explain or show your reasoning. So let's identify an outlier. We have our IQR, which is equal to 5.274, or 5,274. I'm going to calculate 1.5 times our IQR, 1.5 times 5,274, and I'm going to calculate this value because I'm going to need this value to both calculate my higher outlier and my lower outlier. Now in this case, I'm going to choose to see if we can come up with a value that is a higher outlier. So when I calculate this, I get 7,111. So I know any value that is higher than 1.5 times our IQR plus our Q3 is going to get me an outlier. So we know 1.5 times our IQR is 7,911 plus our Q3, which is 19,070. So any value in addition to those, I can't. I apologize for that brief pause. I realized that I couldn't do these calculations in my head, so I went ahead and I put them in a handy dandy calculator, and I calculated 26,981. So I would say an example of a number of followers that a very popular band might have that would be considered an outlier for this data would be 30,000 followers. I wish I had that many followers. So 30,000 followers would be an outlier, and I know it's 30,000 followers because it is higher than 26,981. Question 2. Give an example of a number of followers that a relatively unknown band might have that would be considered an outlier for this data. Explain or show your reasoning. So over in this one, we're looking for a value that is an outlier that is on the lower side of our data. So the formula we can use for that is Q1 minus 1.5 times IQR. We've already calculated our IQR times 1.5, and we got 7,911. Our Q1 is 13,796. And now we are all going to pull out our handy dandy calculators to take a second and calculate this value. And if we do it correctly, we are going to get 5,885. So 5,885 is the lower boundary for our outliers. So if somebody had 5,000 followers, that would be an example of a band that has an outlier on the lower end of the data set. This is my reasoning that you can use to explain this problem. If you need a pause to identify how to do these calculations, take a second and pause now, just like I did, in order to study that question. We're moving on to problem 6. The weights of one population of mountain gorillas have a mean of 203 pounds and a standard deviation of 18 pounds. The weights of another population of mountain gorillas have a mean of 180 pounds and a standard deviation of 25 pounds. So we've got our means and our standard deviations, our second mean and our second standard deviation. Andre says the two populations are similar. Do you agree? So I notice that the mean of this population is greater than the mean of that population. And the standard deviation here is lower than the standard deviation there, but it's actually not that much lower. 18 compared to 25 is pretty similar, even though it's 7 points across. However, these are 23 pounds less than those ones in general. So with the standard deviations being so close, but the differences of the means being pretty different, I actually don't think that the two populations are similar. I think on the whole, the one population is actually about 20-something pounds less than the second population because the means are different, but the standard deviations are close enough, so it's not like the two values are going to start overlapping for most of their data. It's like we shifted the 203 pounds down to 180 pounds, and we have a similar set of data, but in two different places. So my answer to that question would be no. Problem 7. The box plot represents the distribution of the amount of change in cents that 50 people were carrying when surveyed. The box plot, so that's this box plot right here. Then we have this box plot, which says the box plot represents the distribution of the same data set, but with a maximum 203 removed. Wow, we see how this tail got so much shorter once we remove that data. The median is 25 cents for both plots. After examining the data, the value 203 is removed since it was an error in recording. Explain why the median remains the same when 203 cents was removed from the dataset. So, in this case, we only removed one value from the dataset, which means if we were looking for the median of our set of numbers, probably the two middle numbers or the middle three numbers were somewhere around 25 cents, which is the median. So when we remove that data, the median didn't actually change because so many of the values were 25 cents. If the middle value is 25 cents and the one bigger than the middle value is 25 cents and the one less than the middle value is 25 cents, removing one piece of data just shifts that middle value to the right or the left one. It's not going to shift more than that because we're not removing more than one data point. In that way, the median actually stays the same despite this one having the data point and this one not. When 203 cents is removed from the dataset, does the mean remain the same? Explain your reasoning. Remember, when you have an outlier in the data, having that outlier is going to take the mean and it's going to shift it in the direction of the outlier. So in this case, when you have that 203, it's going to shift the mean in the direction of the outlier, which means the mean's probably going to be greater, or it will be greater in this case. Once we get rid of it, it's going to shift that mean back down, so the mean becomes smaller. So when the 203 cents is removed from the data set, the mean does not remain the same. It actually becomes smaller. That is our last question. I hope you enjoyed this and all of the Unit 1 videos. If you have any questions, please leave them in the comments. As always, like and subscribe, and I'm looking forward to seeing you in the next one.